In the previous video, we talked about the various properties of liquid. In this video, we are going to be talking about one very unique property that you've not learned about till now, vapor pressure. So vapor pressure, before we start all of that, when you have a liquid, you have it in outside conditions, or you place the liquid outside, what happens is it undergoes the process of evaporation. Evaporation happens because the intermolecular forces in between the molecules of the liquid is not strong enough for it to hold all of it together. So over a period of time, little by little, you have the molecules getting escaped into the atmosphere. Now, imagine you have a closed container. So when you have it as an open container, you have the process of evaporation taking place, which means the molecules are going to escape. Now, imagine we have a container which is closed, completely sealed tight, and it is like you kept the container out there. So initially what will happen is you will have only the vapor at the top, the gas. Okay, it's empty, or rather, instead of saying vapor or gas, I would rather say you have an empty space over here. We're removing the entire gas also, which was present. We're removing all of that. You have an empty space over here. And you have the liquid. First, what will happen is the process of evaporation will take place. Right. And this in turn will lead to a decrease in the level of the liquid. Okay, first evaporation will start taking place and this will lead to a decrease. But since this is a closed container, these molecules cannot escape into the atmosphere. They are stuck over here. So what will happen is over a period of time, it will reach this point where the number of molecules that are getting evaporated will undergo the number of molecules which are getting evaporated will be equal to the molecules which are getting condensed. Now, evaporation is taking place because the molecules are not held by strong intermolecular forces of attraction, so they have a tendency to escape. Condensation will take place because these molecules, let's say this one and this one, is closer to the surface. The molecules which are present over here will be able to pull it in, and because of that you have the process of condensation. So there is this particular thing where the number of molecules that undergo condensation is equal to the number of molecules that undergo evaporation is called as a dynamic equilibrium. So basically it means that there is an equilibrium in between these two processes. Okay, so in the beginning of this whole, when we had just the container with the liquid and the gas was completely removed and the container is closed, we had the process of evaporation only taking place. But after some time, there came a point where the number of molecules which there were certain number of molecules which started getting condensed. And there will come a point where the liquid will not change its volume because the number of molecules which undergo evaporation and condensation is equal. And it might seem like the liquid stopped undergoing the process of evaporation, but that's not the case. Despite it looking like that, it's because the number of molecules which are undergoing evaporation is equal to the number of molecules which are getting condensed. You have this equilibrium that is getting formed. Okay, and this equilibrium, this particular state at which you have both the liquid and a gas. Okay, now the vapors which are present over here will tend to exert a pressure, and this pressure is called as vapor pressure. Now vapor pressure is basically the pressure exerted by the vapors in equilibrium with its liquid at a particular temperature. So it's also called as a saturated vapor pressure. Okay, and this property depends upon the temperature, and it is a property of the liquid. It will not depend upon the amount of liquid, but yeah, it depends upon the temperature as well and the nature. So I'll just recap. First, we had a vessel and you had water in it. We removed all the gas from the vessel, so this area is empty, and you have it as a closed container. Some amount of water will start escaping into this area. Okay, and what will happen is the water level over here will start decreasing. There will come a time when there will be no further decrease in the volume of water. So what is happening over here is you have the liquid undergoing the process of evaporation. Not only that, at the same point in time, you have these liquid molecules, or I'm sorry, I should say gas molecules which tend to undergo the process of condensation. So what is happening is when there is no further increase or decrease, further decrease in the volume of the liquid, it means the number of liquids which are escaping is equal to number of molecules of the gas getting converted back to liquid, which means, again, to simplify it further, number of molecules that undergo evaporation equals to the number of molecules that undergoes condensation. So at this condition, the gas, the vapor present over here is able to exert a pressure, and this pressure is called as vapor pressure. So the pressure exerted by a molecule in the uh, vapor phase in equilibrium with its liquid at a given temperature is called as vapor pressure. Now, vapor pressure depends upon two things: nature of the liquid and the temperature of the liquid. Now, nature of the liquid, now suppose you have a liquid which is having a strong intermolecular force of attraction. What will happen? These molecules don't want to let it go. So it will not undergo the process of, it will not like, it, the vapor pressure might not be very high because the number of molecules it's letting out is going to be very low. For example, alcohol and water. Okay, alcohol, simple example, nail polish remover or sanitizers, they immediately evaporate, right? So these molecules do not have as much strong amount of interaction or attraction between the molecules than water takes a bit of time to evaporate. So there is a difference in terms of the amount of time it takes for it to evaporate, because the intermolecular forces of attraction between the molecules of alcohol is relatively less than that of the molecules in water. Next one is temperature of the liquid. Now, assume you are having two conditions where maybe it's a hot day. Okay, you might notice that the alcohol evaporates quickly than compared to on a very cold day. And also maybe like when you heat water, you see that it's evaporating quickly. But then again, that's another story altogether. But yeah, temperature of the liquid just means that on a hot day and a cold day, when you compare these two, and when you're using sanitizer, you'll notice that the alcohol does not evaporate as quickly as it does on a cold day. And this is because the rate of the rate of evaporation of that particular liquid will change with temperature. What happens is when there is a high temperature, the kinetic energy of these molecules is going to increase, and the kinetic energy will in turn make sure that the molecules of the liquid will easily evaporate. So these are the two factors the vapor pressure of a liquid depends on. Now, when we talked about all of this, we only spoke about vapor pressure and we spoke about the room temperature conditions. But boiling is a process which does not take place in room temperature. Boiling actually takes place at a relatively higher temperature. Now, you won't say 100 degrees Celsius is the temperature at which water boils. No. Oh, yeah, you do say that water evaporates. Sorry. We won't say 100 degrees Celsius is the temperature at which water evaporates. Water evaporates even in room temperature. Boiling, on the other hand, what happens is, till here, we learned about vapor pressure, where the pressure exerted by the molecules when there is an equilibrium in between condensation and evaporation, right? So this vapor pressure, when it becomes equal to the atmospheric pressure, then that process is called as boiling. Boiling is when you have the vapor pressure being equal to the atmospheric pressure. Now, in this temperature, vapors will be formed and quickly get exposed. Basically, they leave from the container, and this is going to form through these gases will form through bubbles, and this process is called as boiling. Now, the temperature at which boiling takes place is called as boiling point, and different temperatures for different substances you have as a boiling point. Not only that, the atmospheric, now one more thing, the atmospheric pressure also affects the boiling process. For example, if you are at a higher altitude, if you go to a hill station, water will boil at a much lower temperature than when you are at sea level. So that particular that is why we use things like pressure cooker in places where you to cook the food properly, to make sure that the food is cooked at higher altitudes, especially because the water tends to boil at lower temperature. Now, this image is an autoclave. An autoclave is something that is used to sterilize surgical instruments. And what they do is they put in more pressure. They add in more pressure. They make sure the vent is covered. They add in more pressure. This is just to ensure that the whatever surgical instruments are used are sterilized properly. Okay, now here in this graph, you have two things over here. This is the normal boiling point. Normal boiling point is the vapor pressure of a liquid when when it becomes equal to 1 atmospheric pressure. So at 1 bar pressure, you have it at pressure 1 bar. Notice I said 1 atmospheric pressure. When it's at 1 bar, it is called as standard boiling point. That's a difference, very, very important difference between these two. Normal boiling point is when the vapor pressure will be equal to 1 atmospheric pressure. However, when you have a standard boiling point, that is basically 1 bar pressure. Okay, the pressure is 1 bar. So standard boiling point is actually quite low, slightly lower than normal boiling point, because 1 bar pressure is slightly lesser than that of 1 atmosphere temperature. Now here, this point, this particular line, this is the temperature for the normal boiling point. Now, if you notice 373 Kelvin, that is 100 degrees Celsius, is the boiling point of water. You have 351.3 Kelvin, that minus 273 will give it to you in Celsius. Okay, so this is the normal boiling point of water. However, the standard boiling point of water has been found slightly less, which is at 99.6 degrees Celsius. So it is slightly lesser, and that is found as 99.6 degrees Celsius. So when the atmospheric pressure is, when the pressure is 1 bar, the boiling point of water is going to be 99.6 degrees Celsius. When it's 1 atmosphere pressure, it is 100 degrees Celsius. Now, if you remember, when we talked about boiling, or rather when we talked about liquid being heated in a closed container, when we talk about liquefaction of gases, there is a certain point up to which you can see the difference between the liquid and the gas, and then suddenly it starts becoming you have a clear boundary between the liquid and the vapor. But then there comes a point where you do not see that, when the critical temperature is reached, you do not see that boundary very clearly, and that temperature at which the density of the vapor is similar to that of the liquid is the critical temperature. One more important thing, when you have a liquid and you have it in a closed container, the process of boiling will not take place. So and also when heated, the vapor pressure is going to increase, and that's what we discussed in a few minutes before. So that's about vapor pressure and the concept of boiling. I hope you understood it. Basically, you know, it's all to do with the fact that boiling as a process takes place when you have the vapor pressure of that liquid is equal to the atmospheric pressure. In the next video, we'll be continuing with the other two properties which are left. I think we'll be doing one of them, that is surface tension.